Alright, ladies and gentlemen, we're going to be doing substitution method, and I think y'all can handle it pretty good because y'all are such a good group of students. So, first you have to follow the steps. If you don't follow the steps, it can get confusing. So step 1, solve one variable in at least one equation. Now, when we get to this substitution method, we know 4 steps. We know 4 ways, not 4 steps, but 4 ways to solve systems equations. We got graphing, we got matrix, we got substitution, which you're learning now, and elimination, which you're going to learn tomorrow. Substitution, you're probably going to use when you have at least one of the equations already solved for a variable. If it's not, then you're probably going to use a different method because it would be easier to use that different method. Substitution is only better in certain areas, and usually it's better when step 1 has already been completed. But if it's not and you have to do it, which you have to tomorrow, you solve one of the variables for at least one of the equations, and I'll show you what I'm talking about later. Step 2, substitute the resulting expression into the other equation. This is after you solved it for one of the variables. The idea is that you're eliminating basically one of the other variables, and you're going to only have one variable to solve for, which number 3, that's what you're going to be doing. You're going to be solving for the remaining variable. Number 4, after you solve for that, you're going to plug that value back into the equation, and you're going to solve for the last variable. Number 5, you're going to write the ordered pair. It's not real hard, so you can do it. I'm pretty sure you can. So let's do the first example. Y equals 2x, y equals x plus 5. Now, first step, solve for one variable in at least one of the equations. Well, guess what? Both of these are solved for y equals. So both of them are solved for a variable, so you don't have to worry about that step. Normally, if this was a test, you would probably use your graphing calculator and graph both of these and see the intersection, because they're already y equals. It would be pretty easy just to plug it in and hit graph and second trace and calculate and intersect. But we're going to have to do substitution. So this is what I'm going to show you. You pick one of the equations, since they're both solved for a variable. I'm going to pick the first one. Y equals 2x. That means 2x equals y. That's the value of y. So in the other equation, step 2, I'm going to plug it in place of y. So y equals x plus 5. But instead of y, I'm going to put the 2x. Now step 3, I'm going to solve the equation for the variable. So 2x equals x plus 5. I'm going to subtract x from both sides, and I get x equals 5. Done. Fourth step, substitute that value into one of the other equations. Now since they're both solved for y, it doesn't matter which one you pick. In fact, it doesn't ever matter which one you pick, but it's just easier to plug it into the one that already has a variable solved for. So let's pick the first one. Y equals 2 times x. Instead of x, I'm going to put the 5. So y equals 10. My ordered pair is 5, 10. That's the intersection. That solved the system of equations. So let's do a little bit harder one. Here we have 2 equations, 2x plus y equals 5 and y equals x minus 4. The y equals x minus 4 is already solved for a variable. So, step 1 is completed. Now we have to do step 2, plug it into the other equation. So 2x plus y equals 5. And instead of y, I'm going to put x minus 4. Because that's what y equals, x minus 4. So, solve the equation, 2x plus x minus 4 equals 5. Collect like terms, you get 3x minus 4 equals 5. Add 4 to both sides, you get 3x equals 9. So x is going to equal 3. Now that we have our variable, we're going to plug it back into the equation and get our other variable, the y variable. So I'm going to use the one I circled at first, y equals x minus 4, because it's already solved for y, and that's what I have to solve for. So y equals x minus 4 from right here. That's where I got it from. But instead of x, I'm going to put 3. So that's what we found out x equals. So 3 minus 4 is negative 1. So my ordered pair is 3 comma negative 1. That's it. Let's try another one. Now if you look at both of these, neither one is solved for a variable. So I'm going to have to pick one to solve for a variable. Now you could pick either one. If it was me, I would pick the easier one, which in my opinion would be this one. Because x is over there by itself, it's not being multiplied to. So it's easy, all I have to do is just add 4y to both sides. Let me show you. X minus 4y equals 11. I'm going to add 4y to both sides. And I get x equals 4y plus 1. I solved it for the variable. Now, I'm going to circle this. The reason why is because later on, I want to be able to use it again. So I want to know where it is, and I'll show you why. But first, let's keep going with step 2. Step 2 is I'm going to substitute the resulting expression, which is 4y plus 1, into the other equation. So let me take this one over here, 4y minus 5. Now this is telling me that x is 4y plus 1. So I'm going to put parentheses instead of x equals 9. And I'm going to put this right there. 4y plus 1. Alright? Because that's what x is. It's 4y plus 1. We solved for it. So now I've got to simplify this problem. I only have one variable left. So, how you simplify it? You write down the 4y, and then negative 5 distributes. So you get negative 20y minus 5 equals 9. Now we can just solve for y. 4y and negative 20y makes negative 16y minus 5 equals 9. Add 5 to both sides, and I get negative 16y equals 14. Divide both sides by negative 16. Alright, ladies and gentlemen, Mr. Navall just saw that he messed up at the very beginning, as you're probably used to. You notice that I put x minus 4y equals 1. It's supposed to equal 11. That's my fault. It messed up the whole problem. So I'm going to redo this problem. Sorry about that. So, alright, we're back to where I messed up. 11. That makes a big difference because as you saw we were going to get a fraction before. So let me continue from here. Alright, so we were adding 4y to both sides. So we could solve for a variable x equals 4y plus 11. There. So now we're going to substitute 4y plus 11 in for x in the original one of the original equations, the one that's left over. So I'm going to take that over here. 4y minus 5 times, instead of x, I'm going to put 4y plus 11 equals 9. So right here I'm going to put 4y plus, not equals 11, plus 11. Alright. Now I'm going to simplify it. 4y, then negative 5 distributes, so you get negative 20y minus 55 equals 9. I collect like terms with these two. So I get negative 16y minus 55 equals 9. Add 55 to both sides. I get negative 16y equals 64. Divide by negative 16 on both sides, and you get y is equal to negative 4. Alright, so now we have our first variable. So remember before when I circled this equation because I was going to remember it? Well, it's already solved for x, and guess what I have to do now? I have to solve for x. So I'm going to, instead of using the original equation from up here, I'm going to cheat and I'm going to use this one because it's already solved for x. It's the same equation. I never changed it. I just moved it around. So, x equals 4 times y plus 11. And y is negative 4, so I'm going to plug that in. So then we get x equals negative 4 times 4 is negative 16 plus 11. So x is equal to negative 5. So now that we have x is equal to negative 5, our ordered pair is negative 5, comma, negative 4. And this will be the hardest problem you run into on your homework. And it's not really that bad. Just take one step at a time. That's it, folks.